Hi, I'm Darlene Barker, and I'm doing a literature review on ShapeNet, a shapelet neural network approach for multivariate time series classification. I will do a quick look at shapelets, the problem that the paper is solving, what they contribute to solving the problem, an overview, and some results. Shapelets are a method for image analysis. You can have a shape be converted into a one-dimensional time series representation, and here we have a leaf and some skulls of horned lizards and turtles. What is the problem that the paper is trying to solve? Their existing works on shapelet selection cannot be applied to multivariate time series classification because of the differing variables of differing lengths, making comparison difficult. And here, the three challenges that they try to solve, implement with ShapeNet is first the multivariables in multi-time series. The shapelet candidates can become very voluminous, heterogeneous, and inaccuracies exist. The second is the difficulty of comparison. And the third, the need for an interpretability of the shapelets. So here, what they're proposing is a shapelet neural network approach to solve the multivariate time series classification problems, which should give these two benefits: accuracy improvement using shapelet embedding. And how they propose doing this is using a multi-length input dilated causal convolutional neural network, which is an enhancement of a previous study in 2018 by Bay, Coulter, and Colton, where they embed the shapelet candidates of different lengths and different variables into a unified space, hence shapelet embedding. The second benefit is interpretable classification results. Instead of feeding nearest shapelet candidates to build the classifier, they first cluster the shapelet candidates embeddings, then use a utility function to select the top k candidates that are close to the centroid of a large cluster and different from other cluster centroids, which gives us representative and diversified final shapelets. So this is an overview of ShapeNet. It learns the variable length time series subsequences of different variables in the unified embeddings, where it captures the interactions between the different variables in the multivariate time series. And in doing so, it creates a classification model, which we have over here. And then the use of this is ShapeNet, and the output is that classification model, which they will use SVN to visualize the shapelets of different variables, separating the time series of different classes in the study. And here are the results. Let's see. Okay. The conclusion of the study is that the classification accuracy for ShapeNet is superior to the 7 compared methods. If you notice the value, we're looking, the total best accuracy is 14 compared to single digits of the others except for Weasel Muse. Okay, so they did accomplish what they were proposing. The one thing here with Wilcox tests, P p-value, they rejected null hypothesis values. So here, the statistical difference, they used a p of 0 versus 0.05. At this point, what they're proposing for further work in this study is to study multivariate time series with missing values, which is challenging for real-world data sets. So here are some references, the paper which I'm reviewing, and some other papers and sites with information. This is one of their references in the paper. And thank you for listening. Any questions?